Hello, today we're going to start our gas law section, and we're going to start with our first law, which is Boyle's law. You are going to need these conversions to do some of the practice problems. If a problem like this comes up on the test and you need to do a conversion, they'll give you the conversion factors here. So 101.3 kilopascal is going to be equal to 1 atmosphere. 101.3 kilopascal is also equal to 760 millimeters of mercury. 0.1013 kilopascal is going to equal 1 torr, and 1,000 torr is going to equal 1 atmosphere. So you will need these for the practice problems. Standard temperature and pressure, that's where most of our gas laws are going to occur. Standard temperature is going to be 0 degrees Celsius or 273 Kelvin. Standard pressure is going to be 1 atmosphere or 101.3 kPa or 760 millimeters of mercury. So this is the typical pressure that is on you on a normal daily basis, not taking weather into account. So Boyle's law says that for a given mass of gas at a constant temperature, so our temperature is not changing, the volume of the gas is going to vary inversely with pressure. So the volume of the gas is going to change as we change the pressure, and inversely means in the opposite way. So if you increase the pressure, the volume of your gas is going to decrease. They're indirectly proportional is another way to say inversely, so they're going to change in opposite directions. So when the pressure of a contained gas increases, the volume is going to decrease, and when the pressure of the volume decreases, the volume is going to increase. So they are inversely or indirectly proportional. So if we look at a graph, you can see that as the pressure increases, our volume would be going up. This graph has the volume increasing, and as we increase the volume, our pressure is decreasing. So the product means we're going to be doing multiplication of pressure and volume at any two sets of conditions. That's going to be our initial and our final, is always going to be constant, which means we should be able to set them equal to each other. So that's going to give us our equation P1V1 equals P2V2. P is going to be for pressure. Your units just need to be the same going both ways. And V is going to be for volume. Again, units need to be the same. 1, so P1 and V1 are going to be your initial pressure and volume. 2, your P2 and V2 are going to be your final pressure and volume. So you're going to be given 3 variables and asked to solve for the 4th. So we have a high altitude balloon that contains 30.0 liters of helium at 103 kilopascal. They want to know what is the volume when the balloon rises to an altitude where the pressure is only 25 kPa. So the first thing you need to do is identify your variables. And I would suggest making a list or highlighting them and labeling them in some fashion. So we have 30 liters of helium. Liters is a unit of volume at 103 kPa. kPa is a unit of pressure. Since this is what we are starting with, these are going to be our V1 and our P1. They want to know what is the volume, so we're going to be looking for V2 when the balloon rises to an altitude where the pressure is only 25 kPa. So this is going to be our P2. So now that we have identified our variables and which one we're looking for, you can take your original equation, P1 V1 equals P2 V2, and rearrange so that the one that you're solving for is by itself. So we're looking for V2. That means we have to get rid of P2. So now we can plug in and solve. So our P1 is 103 kPa. Our V1 is 30 liters. And our P2 is 25 kPa. So our kPa's cancel. We're left with liters, which is what we're trying to find. They asked for volume here. So 103 times 30 divided by 25 gives us 123.6, and we need to go with 3 sig figs, so we're going to round this to 124 liters.